Good afternoon and welcome. This afternoon's session, cloud-based machine learning for the developer. If that's not the session you intend, I would suggest you're in the wrong room. Now would be the time to make that split. This afternoon we have 75 minutes to achieve two distinctly different goals. One is to introduce end-to-end what is machine learning and how can this be achieved with Azure Machine Learning. And the second is to talk to the audience of developers, whether you're a software developer or a database developer, and how could machine learning be relevant and approachable for you. My name is Peter Myers. I'm an independent business intelligence expert. I've spent a decade and a half working with data, and I've evolved since SQL Server 7 to master the full breadth of the business intelligence capabilities that Microsoft have on board. Now, interestingly enough, SQL Server back in the 2000 release was the first relational database product to include data mining as part of its feature set. So it was my first taste of what I could achieve in predictive analytics. And of course, with the release of SQL Server 2005, I was keen to become much more thorough with the experimentation with what I could achieve with SQL Server data mining. And where that's led today is that I occasionally, when working as a consultant, remind customers of the potential of their data and how it can be used in a recycled sense from collection right into predictive analytics. And so today's topic takes it to a whole new level with cloud-based data mining, which we now refer to in more modern terminology as machine learning. So what I have to share with you today is my curiosity, passion, experience around machine learning and with the latest and greatest with Azure Machine Learning. The session outline then is to introduce the basics. We assume no knowledge about whether you've worked in machine learning before. Having introduced the basics and set the scene for a whole series of demonstrations, we'll introduce what Microsoft are delivering as their cloud-based predictive analytics service with machine learning. Demonstrations end-to-end to follow through with the machine learning flow, and then we'll wrap up with business scenarios and a summary. Okay, it's human nature that we have this need to know what could be. But I wonder what your manager's reaction would be if you started to consult the likes of a clairvoyant to determine what could be. Now, in fact, if you think that today's topic is about clairvoyants and psychics and oracles, the different type of oracle, I suggest it's a different session and probably a different conference that you would be going to learn about these types of predictive techniques. All right, one goes, goodbye. Perhaps I could interest you in this approach. So the octopus, and well-regarded with the 2010 World Cup, was it, with a 100% rate of accuracy, being able to predict the winners of the final games. So can you imagine your manager's reaction when you suggest that your data center should also include an aquarium? And we could host these mollusks to assist us in our business needs. Well, again, if this is a topic of interest to you, I'm sorry to disappoint you, but that's not on the agenda today. A little more basic, we're going to go into definitions now of what is machine learning. It's about good data science and good data combined. Now, according to Wikipedia, machine learning is a subfield of computer science and statistics that deals with the construction and study of systems that can learn from data rather than follow only explicitly programmed instructions. All right, lots of words. How about we back this up with a scenario or two? I need to add two numbers together. And I recognize that I need a function that takes two inputs, number one, number two, and because I develop in C#, I can very quickly develop this type of solution. All right, very basic. Let's make it a little more interesting by proposing a different requirement. I need to predict customer profitability. And I could detect that the function that I'm looking for will require inputs like age, marital status, gender, etc. And then I open up Visual Studio and I start to write a method like this. Could anyone even suggest what the lines of code would be that would take those inputs and output a reasonably accurate and reliable prediction? All right, well, I have one hand raised. It's actually quite rhetoric. I don't want an answer to this question because it really wouldn't make a lot of sense. We're going to say that if you're attempting to solve this problem by using Visual Studio in the language of your choice, that's not the way to go. Instead, and what you will learn in this session is that you can take well-prepared, good quality data And then we can use machine learning engines and algorithms to detect patterns. And those patterns become queryable and may be exposed as a service. And we will then hit it to seek predictions. So therefore, no code to develop the prediction model itself. That very much sets the scene for the demonstrations I have in this 75-minute session. We're going to solve this problem about how can we predict customer profitability and use it to our benefit to add value back in an ASP.NET web application to deliver targeted advertising. Let's start with the basics. Machine learning flow. I think this applies really to any project that you work on, that you do need well-defined and clear objectives. So we start with that. And the next thing is we look at what data we have available, internal data, external data, what value do we get by combining different data sets together to enrich our data. Preparing the data is then looking at quality. What happens if we've got missing values or insufficient volumes? And then we come to the heart of it, training models, taking data in, algorithms and engines working together to detect patterns, and their output is a model that becomes a queryable resource for predictive purposes. Now, we wouldn't suggest just create the one model. For those that are interested in machine learning, I hope you have a background in curiosity and passion, because we're going to suggest that you create many models, and then you'll use scientific approaches to evaluate which one is more accurate, reliable, and useful, at which point you can then publish this as a service, and then we can hand it back to the ops team to manage this to ensure that it's reliable, available, and performing well. And then at the same time, we're going to hand it across to a developer and ask them to integrate this as a predictive capability into an application. So here is the flow that sets up the demonstrations for this session. Let's then begin with the roles. I'm going to introduce 3 roles here that would be relevant to machine learning. The first and the most obvious that we hear about is the data scientist. By show of hands in this room today, are there any data scientists? Not one. Just as well, because there was. Oh, there's one in the back. All right, how much money do you earn? And please don't answer that question. But let me share back to the audience that on average, the gentleman in the back that is the data scientist earns much more than on average the software developer or the database developer. And good reason for this. Data scientists are well-skilled, educated professionals. They've probably got a basis in computer science, and they've extended this to master's and PhD level with mathematics, statistics, and so on. Now, certainly machine learning is a target for this group of professionals, so they're ones that actually architect and design machine learning platforms themselves. But with our focus today on the developer, I'm going to introduce that the data professionals such as myself, a business intelligence expert with expertise in designing solutions with data, I think that I'm a perfect target for learning machine learning and what it can do to take my skills and capabilities to a new level. Additionally, a software developer, an ASP.NET developer, a .NET developer, any type of developer, could also benefit from either learning machine learning or learning how to integrate machine learning into their applications. So I'll be talking to all 3 groups today, and in fact my demonstrations will really focus on data professionals and software developers, because the message of this session is that machine learning really is for more than just data scientists. And I have a good message for you to recap that by the end of this session. Now, when we look at the challenges related to machine learning with the data scientists primarily producing these solutions, the traditional approach has been typically very expensive. The hardware, the software, the skills that must come together mean that there's a barrier to entry. Smaller and medium-sized and even larger-sized businesses are yet to take the risk and invest in dedicated machine learning and data science resources. When it comes to the data that you have, another challenge would be, how do you gain access to it? How do you combine it? How do you prepare it? And it's a whole new set of tools that you might need to consider here, so we end up with chaos. And of course, there's complexity across the whole layer. And one interesting area of complexity today with machine learning approaches is that while you may eventually produce the most optimized, accurate, reliable predictive model, the next challenge would be, how do I embed that into our real-time web application? and ensure that it's fast. And so there's a whole new challenge and a whole new set of skills. So Microsoft, as we will demonstrate to you in this session, have addressed many of those concerns and complexities, and at the same time making it approachable to an entirely new audience and making it easier. All right, so let's introduce what Microsoft are now delivering, branded as Azure Machine Learning. It enables powerful cloud-based predictive analytics, such as professionals like myself can easily build, deploy, share advanced analytics solutions. Now, here's a key point, that I don't need to install any hardware or software. I just need an HTML5 compatible browser. I need internet connectivity and access to the Azure resources. And I love this example, is that when I take my flight home from Chicago to Seattle on Saturday, I could connect to the in-flight internet and I could be machine learning for the couple of hours as I'm traveling home. It retains a practically unlimited number of files on Azure storage, and it allows connecting seamlessly with other Azure data-related services. So big data and machine learning come together very easily. SQL Azure databases that you have can also be used as sources for machine learning and your virtual machines. Clicking next. All right, how does it work? All right, well, first step is in the Azure portal. We need to set up a workspace for our machine learning. We can then hand it off to the data scientists, the data professionals, to use ML Studio, a web-based drag, drop, connect, configure environment to upload data sets, define experiments. And at the point in the cycle where that experiment has produced an accurate, reliable model, it can be published as a web service whereby we hand off to software developers and they can then interact with the web service methods. That leads me nicely into the first demonstration. And I'm wearing the hat of the Azure Ops team here. So here I am in my Azure portal, and as simple as scrolling down to the machine learning section, I'm going to go ahead and create a new ML workspace. The only hard part is coming up with a unique name that nobody else has. So I'm going to say AML Ignite. The second one is an Azure storage. So everything that you're doing in machine learning is stored in a corresponding Azure storage. So as simple as this, I am provisioning a workspace, and that's going to take maybe 1 or 2 minutes to complete. All right, let's go back to the machine learning flow, and this sets up the agenda for a series of demonstrations, starting with defining the objective. A reminder here that it's important to start with a clear and well-defined objective. Today that will be, I simply need to predict customer profitability to deliver targeted display advertising on the company e-commerce website, in turn to present relevant product suggestions and hopefully to increase sales and profitability. So it's nice to have that type of objective that you can always refer to. Are we on track with meeting this objective? Step 2 is about collecting your data and sufficient volumes of current, clean, and complete data. And I always like this term, the garbage in, garbage out. We talk about it in data warehousing, but it certainly applies to machine learning also. Garbage in, garbage patterns, garbage predictions. Now, the data that you collect can come from really anywhere. You can consider internal sources with operational data, external sources including market intelligence data, weather data, with the understanding that when you start to relate data sets, you make it much more interesting and richer, and therefore opening up the potential for the discovery of interesting patterns that might stabilize or produce far more accurate predictions for you. The demonstration then here is about collecting quality data. So to keep things reasonably straightforward and simple for the purpose of this 75-minute session, I've already retrieved the data from the data warehouse. This is for my customers and their profit. The tool of choice, because I have such a low volume of data, will be, in fact, Excel. And this is a nice opportunity to promote the brilliance of the Power Query add-in, which I'm going to use then to connect to the CSV file, and we'll take an exploration of that data. All right, so using Power Query to connect to the CSV file, and I appreciate that that might be very small, but let me just step through the basics of this. I have about 10,000 rows representing one row per customer. Details like the customer ID, their first name, their last name, their current age, marital status. Now, when I go to filter this, you'll see that there are only two distinct different values found in this column. They're either married or they're single. When it comes to gender, they're either female or they're male. When it comes to yearly income, we'll see that the data has already been prepared in such that the data has been discretized into brackets of 0 to 25,000, 25,000 to 50,000. Total children, I'll point out that there's a null here, so we do have some missing data, and also for the number of children at home, we have a null, so we'll need to take some care and maybe do some preparation with it. Education, occupation, are they a homeowner? How far do they travel to the workplace? Everything that I've given you so far comes from our customer dimension table in the warehouse. We've been fortunate to maintain some good quality profile data in the e-commerce web application. Now it's coming back to help us in the machine learning activities. Now, I've taken that data and I've joined it to sales history for the past 12 months, and I've simply made a request of what was the profit generated from each of these customers. We will return. The next step in the flow then is about preparing the data. So often significant effort is put in at this stage, and it pays off in producing a far more reliable and accurate solution. There are books written just on how you should prepare your data, and so significant effort and time could be spent here, whether it's transforming to cleanse, reduce, reformat, to identify abnormal data. What do you think you might do if you find some unusual records in there? Remove it? Quite possibly, it might skew results, but it depends on the activity. If you're looking to detect fraudulent or abnormal behaviors, you might actually leave them in and oversample them to exaggerate them. So it will depend on your objective. You'll go back and understand, what am I trying to achieve here? Missing values like the total children, number of children at home, what are we going to do there? And we'll address that shortly. The categorization of continuous numeric values, and we see evidence of that with both the yearly income and the commute distance. And the normalization, so continuous values could be normalized between 0 and 1. There are different techniques that have different reasons associated with them, depending on the activities that you have. Now, of course, having the required data to begin with is important. And because this is an audience of developers, I'll use the opportunity to remind you that when designing an e-commerce application, for example, and you need to define the login for your customers, of course, you want an email address to email them, you want a password, but don't just leave it at that. Within legal boundaries and good taste, go ahead and extend the definition of the profile to bring in questions about, well, what is your age? Where do you live? How much do you earn? And so on. But please avoid the problem that we refer to as the Afghanistani accountant problem. Why do you think an Afghanistani accountant might happen here, or what the problem could be around it? So as developers building the profile page as a data entry screen, and you're going to default your drop-down list to the first item, what do your shoppers want to do when they just want to get to the checkout for their first purchase? Next, 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 all right? Now, if you're going to use the first item in the drop-down list, you're likely to end up with lots of whatever's at the top. And then when it comes to preparing your data, you're going to find that you've got an awful amount of Afghanistans that happen to be accountants. What are you going to have to do with those, all right? And more than likely, you may have to remove those cases from your data. So to the developers, try and enrich the data that you have. Try to keep it clean and try to keep it current as well. And it will come back to you later on as a beautiful wealth of data to support predictive analytics later on. Alrighty, so the demonstration here is taking it to the preparation of data. Now, while I have a continuous numeric value here describing the profit produced by each customer, if I'm going to use this in a predictive scenario, we would refer to that as a regression activity. I want a model that will predict a single numeric value, how much profit. to simplify this, I'm going to switch it to become a classification task. So therefore, I'm going to categorize each customer into either very low, low, medium, or high profit. And all we're going to ask of our predictive service is which of those categories does a particular customer likely belong to. And that's why I like to use Power Query here. I'm going to use the add column, and I'm going to use Power Query's capability here to add a new column called profit class. And Power Query is a very, very sophisticated tool. It has its own language like this, using M, that if profit generated is less than 500, then return the text of very low. Else, if profit generated is less than, in fact, that should be 100, the second one is less than 500, then this is low. The next test would be, if it's less than 1,500, then medium, else anything left over will be considered high. So this is just one technique that you can use to help prepare your data. And let me take it to another level by adding a step here that will group by, and it will just give us a count. And this gives us an idea then of the distribution of our customers across the different categories that we've designed. All right, I can delete that step, don't need it. The data is now prepared with an additional column. I'm then going to load that into an Excel table, and then I'm going to save this as a CSV document and upload it to the workspace as a data set available for experimentation. So as a CSV document, I'm going to rename this as the customer profit prepared. And then I'll close Excel. Part 2 will then, and remember I'm wearing the hat of the data professional, now that the workspace has been provisioned, the Azure Ops team have then granted access to me to work in this workspace. And then I go ahead and sign into ML Studio, so a web browser studio tool, drag, drop, connect, configure environment for experimentation. Let's ignore the welcome for today, but the new data set is the option I'm now looking for, and I'm going to upload that CSV document to make it a resource available to us in our workspace. So the data that you do machine learning against needs to be in the cloud or accessible from the cloud. Okay, that won't take too long to update. And so what you'll then appreciate is that your workspace can contain a collection of data sets that then may be reused across many experiments within the workspace. Okay, we'll come back to that. Moving on, so the next two phases in the flow, training model, evaluate model, this is really an iterative process. We don't suggest that you just create the one model and then say, this is terrific, just publish it. It really is a period of time for you to experiment. What if I used a different set of data? What if I prepared it differently, or use a filtered subset, or I use different algorithms? And there are so many variables that we can play with at this point. It's why data scientists get paid so much money, because they're really there to discover the most optimal combination that will deliver the most accurate, reliable, and useful result. For us as data professionals, we can still work within those rhythms, but perhaps not to the same intensity. So, training a model involves the selection of an algorithm, defining inputs and outputs, and optimizing the parameters to do the best they can based under the circumstances. What will guide you here is either documentation, samples, or just experimentation. What would happen if I did this? Does it produce a better outcome? Ultimately, iteratively working through this, we're looking to discover and therefore prepare for publication an accurate, reliable, and a useful result. So, switching back to the workspace, we should now see that the data set has in fact been uploaded. We're now in experiment mode, and so I'll go ahead and add a new experiment. And before I create a blank experiment, let me use this opportunity to show you the vast collection of samples available to you to kickstart. So maybe you don't need to start with a blank. You'll find a sample that represents the objective that you have, and then you'll work with it directly, and its accompanying data sets and documentation. Having learned from it, you then might come back with a blank experiment and start working on your own data. So today, starting with the blank experiment, the first thing you do is provide a good name for the experiment. So predict customer profit class. What you see on the left-hand side are the modules and resources that you can drag drop into the designer. On the right-hand side, you have the properties that allow you to configure the in-focus resource. So here under the saved data sets, we should find in my data sets that the customer profit prepared is available for us. And when you right-click the little dot down the bottom, you may visualize this data. And it has its own tool here to allow you column by column to determine what your data looks like. Now, you don't see it immediately, but when you select a column, you get additional statistics and visualizations to help you down here. All right, so notably, we'll take a note and see that customer ID, first name, last name, do we think that those would have any impact on whether your profit is low or high? Whether your name is Peter, John, Mary, or Joanne, would it matter? Maybe, maybe not. So we might then just say, let's drop these out. Although I'll say that the data scientist might say, we're not going to drop anything without some type of interrogation. In fact, if we didn't have gender available to us via lookup tables, we could use the first name and determine and derive additional information. Today, to keep things very simple, we will quickly dismiss the first three columns. The ID, first name, last name. We suspect that age, marital status, gender, income, and the children will have some type of impact on profit, which we ultimately see at the end of the list. Now notice here that total children has 10 missing values. All right, and I should have pointed out to you in the top left corner here, we have 10,000 rows. So 10 out of 10,000, I think we can work with that. We'll substitute any missing with the value 0. And yet when we take a look at the number of children at home, we learn that there's actually a higher proportion of missing values, almost 50% of the data. So we'll make the decision up front that we can't really prepare this or overcome it with a substitution. We'll drop this one as well. So while you can do data preparation in external tools, and that's certainly a great idea, there's also the ability to prepare your data here within the experiment. Now, before I move on to that topic, I do just want to point out that the other choice would be to bring your data in with a reader, and this is where you may configure the ability to access data from other potentially external locations via the web from a web URL. Hive Query brings big data to machine learning. Azure SQL Database, so any valid T-SQL against your Azure SQL Database, and then Azure Storage and data feed providers. That won't be relevant for me today, so I'm going to remove it. As part of the pre-processing of our data, the first thing I'm going to do is limit the columns. So simply by typing into the search box here and knowing that I'm looking for a module that is the project columns, I find it very quickly here in the manipulation group. Drag, drop, connect, configure. So rather than let's begin with all. Let's exclude particular columns like the customer ID, the first name, the last name, and the number of children at home. Next, we had 10 customers with a missing total children. So simply by typing in the word missing here, I find that there is another manipulation module that will allow me to clean missing data. Drag, drop, connect, configure, and I would begin with no columns and include by name the total children. And then I'll configure the property here with a custom substitute value of 0. And so there's some preparation, and now we're ready to start the real experimentation. Now, it's a standard approach and a good methodology that when you're going to test your model and evaluate it, you're going to reserve some of your carefully prepared data aside. And a common split, usually around 70%, 30%. Of the 10,000 customers that I have, 70% will be used for training purposes, and the reserved 30% are going to be used to test. So we know what the outcome was for the 30%, use the model to predict, and basically what's the ratio of how often it gets it right. It's a very good indicator of accuracy. To assist me here, and I'm going to expand the group down here that is under data transformation. We have sample and split. We have the split down here. So take the cleansed data, pass it into the split, and with a fraction of 0.7, note the way that we may document by double-clicking a module. I'm going to put 70% in there, and you've got a way then of adding feedback and comments into the modules themselves. And now we get into the machine learning itself. Here under machine learning, we're first of all going to initialize the model. And we can narrow this down very quickly, aware that I'm looking to predict a class of profit. This is a classification activity. So I'll expand classification, and then I'm overwhelmed by the sheer number of possibilities here. Now, does anyone see anything obvious that will allow me to narrow these down very quickly? Two-class versus multi-class. Okay, for the classes that I prepared in Power Query, how many did I have? 3, 4, very low, low, medium, high. All right, so it's not two-class, it's going to have to be multi-class. That narrows it down to the first 4. Of the first 4, which one should I use? All of them, right. This is experimentation, and in particular, if you don't have experience, well, this is where you start to get experience. All right, so I'm going to start with the multi-class decision forest, drag it in, and then next I need to do some training. So I have the train model, bring it in. It has 2 inputs. What algorithm is it using? What data is it training against? And then we go ahead and configure it with a single column selection. What am I looking to predict? Profit class. All right. How well did it do its job? Well, remember at school we had examinations. They were there to evaluate how well you've learned a subject. The evaluate model, the score model is what I'm looking for, does exactly this. And this is why we have that reserved data. Using this model and the 30% of data, go and score how well it does its job. All right, now as an experiment, we're not going to stop just here. And let me show you how if I multi-select these 3 modules, Control-C, Control-V, I'm just going to move this across to the side, and this experiment now has 2 different training activities. All right, of course I don't want to repeat using, okay, let me just get the right cursor shape. I want the 4-headed arrow, where are you? All right, let's ignore that. Let me delete the multi-class decision forest, and I'm going to choose the multi-class neural network. Let's put them together, and let's see now whether I can move this across. That looks a bit better. All right, and then finally, to compare the 2, this is where I have the evaluate model. The evaluate model takes 2 inputs. Let's use the left-hand side being the multi-class decision forest, and the right-hand side being the multi-class neural network. All right, now at this point, we've not really been doing much with the service. This is just an HTML application on the client. But when I click run, it in fact saves the experiment, validates that it makes sense, and it starts literally running it. So as a pipeline from data right through to splitting and to training in parallel, and then in evaluation, the service in the cloud is now literally doing machine learning. This will take about a minute. Are there any questions while it's churning away? Yes? How does it define tuning parameters? Right. So the selection of the algorithm itself, you will see they have custom parameters. If you want to know what these actually mean, and I'd hope you want to know if you're going to configure them, note that the selection of any module has the more help, and that will take you immediately across to the topic. And then you'll be able to scroll down and see all of those properties and learn precisely what they're designed to achieve. All right, if you don't know what they mean and it starts to get quite spooky with statistical talk going on at this stage, then leave the defaults on. All right, so it's succeeded. This is great. See in the top right corner, finished running. This is great. To keep this reasonably straightforward, I'm just going to right-click the evaluate model and visualize what the evaluate has found. So in fact, what it's comparing is the two. Let me scroll down to show you that there are metrics and a confusion matrix for the left-hand side, and then the metrics and the confusion matrix for the right-hand side. Given that we have the 4 different classes, we can see here that it's just so amazingly good that 100% of the time it was getting it right. Okay, so that's just spookily too good. That's because my sample data is really not real data, but great for demonstrations. The metric here then, 99.9% versus 93%, we might come to the conclusion that this is the better predictor, all right? So in this simplified example here in demonstration, we're going to decide that this algorithm here did the best job. But this could represent weeks of work, all right? Finally arriving at this conclusion that this algorithm tuned in this way with this set of data has produced the best result.
Shouldn't the data scientists be doing that work?
The question was, shouldn't the data scientists be
doing that work, deciding which algorithm is best?
Not necessarily. So our talk here is to say that this is also approachable for developers and data professionals, that you're able to compare 2 numbers together. It may not be the most optimized result that you could possibly get from that data, but it is adding value in the fact that it is, at some level of accuracy, producing something better than a random guess. Okay? One more question.
In your experiment, you mentioned that you can do alternates by cleaning the data differently. Could you actually do that in the same experiment? Or did you do that?
Okay, the question is about pre-processing or pre-data processing. Yes, there are many things you can do there to help cleanse the data within the experiment itself.
Okay, so like you had that, so you had your file at the top, and then you did the...
You could be filtering, you could be joining, you could be adding calculations and statistical values. So there's many, many things. So the brevity that I have, because of the 75 minutes, we don't go through that, but there's a very rich set of transformational modules that helps you also prepare the data, which is particularly powerful if you had big data coming in and some other SQL Azure data, and you don't really have a single location to bring them together and then prepare them further. So you would do that within the experiment itself. All right, I will defer from questions to ensure I get through the topic, and I'll open up with any remaining time at the end. We're now at the point where we've decided, yes, we've found the model that's proven itself to be accurate and reliable, so we're going to publish it. So the steps here is first then to add a scoring experiment. And this is going to do some manipulation of the design in preparation to publish this experiment to be an optimized web service method. We're going to prepare it for a scoring experiment, and then I'm going to do some manipulation of it, and then I'm going to publish it as a web service. And I'll point out also that gallery of samples that you saw when you went to create the experiment, that's great for you to discover, but it's also possible that you can share your experiments back and contribute back to communities. So just be aware it actually works both ways. So you have the opportunity also to publish your experiment to the gallery for public discovery and consumption. All right, what I'm going to do then is create a scoring experiment. So I think I need to run this again. What I'm looking for, if you look along the bottom, the very last one is create scoring experiment. It needs to be highlighted before I can actually choose it. I'm not quite sure why it wasn't. Okay, I will take that question. Oh, I'm sorry, I won't take that question. But you're first in queue the next time we open up. Okay, do we see that the create scoring experiment is highlighted? Watch closely. I'm going to choose the model. In fact, it was the left-hand side. I choose the model, and then watch the animations. They've done a great job of this. Wow. Remember my opening slide said that what we were looking for was a function that allowed us to pass inputs, and we're looking for a predictive output. What it's doing is modifying the design of the experiment to make it basically a function. All right, I'm going to cancel its tour of what's happened, but let me explain what has happened. Here is our input. Rather than call this input 1, I'm going to call this what it is. It's the customer profile. The output is going to be the profit class prediction. Now, I think I'm going to have to make this a little larger so you can see. Basically, it's connecting the input to the project columns, and then it packaged up a number of the transformations, like the substitute missing values, into an apply transform. What's interesting there is that those transforms become reusable, and they can be shared across other experiments. What you need to do is this, and this isn't so clear, so there's a lot of good value in this session because it's been a lot of gleaning on my side to work it out. Don't just accept what it says. All right, so I'm going to take that and say, well, really, we're passing it into the score model. Now, the other thing I'll point out is that our model is now a trained model. Again, a resource available for reuse in other experiments. So what I'm now saying is whatever the developer passes into the web service method is going to pass directly into the scoring. Now, another tricky thing is that the project columns, I'm going to edit it because we're also going to remove that we don't need to pass in profit generated or the profit class. That made sense in an experiment that was training, but you would never expect the developer to pass in the profit class to get a prediction of the profit class. So by modifying the project columns, I'm actually changing the interface of what the score model expects to be passed in. Therefore, it's a little bit backward, I'm defining the function inputs. I've just removed 2. Now likewise, for the output from the score, I'm going to break it and add in a project columns because I'm only interested in the one column. And that will be what's the profit label that it's predicting. So here, begin with no columns, include just the scored labels. And that's how I have prepared the experiment, now as a scoring experiment, to really expose the function of our desire. Pass in demographics only, pass out a prediction of profit. Let me go ahead and run this, so it's going to validate that all of my configurations make sense, please. Fingers crossed. It's queued. This will take some minutes. I will now take that question if it's still relevant.
If you want to evaluate multiple models at the same time, is there an easy way to do that?
So if you want to evaluate multiple models, so more than 2, yes, you could use an R script to do this. All right. So the evaluate module that you have here is just 2, or you could chain a number of evaluates together, or use R. Oh, okay, that is really undesirable. So that maybe suggests that I have connected this to the wrong place. Why don't we connect it to here and see what happens? X. That apply transform is a very recent addition, by the way. So I think it was only a week or 2 ago that that was added to the service. So let's see that that's now happy.
Did you do that on purpose at first?
No, I didn't. So I did make a mistake. And now it's still wrong. Okay, well, this is real-world troubleshooting. Now let's have a look. So it was happy to this point, the project columns, predict customer profit class. The data being scored must contain all features. Must contain all features using profit generated. Maybe I shouldn't have removed something. Now I rehearsed this just before the session, so I'm like, okay, let's see. Anybody, I mean, I'm happy to troubleshoot this, but anyone want to throw out some ideas? No columns. So you think that this one was wrong?
I think the model that you're using is already a scored model that had specific inputs.
Mm-hmm.
And since you're not able to find that input,
I think my problem is, and I think you might be on the right track, profit generated I shouldn't remove. Let's just try that. Worst case scenario is have backup video, but I don't want to switch to that. So I mean, it should be solved. This is.
Profit generated to determine your class?
So it was expecting it. So the model is using it as an input, and I'd removed it. So what I was supposed to do, and I missed this at the beginning, my first project column should have removed it as well. I'm not interested in the continuous value of what the profit generated was, and so I forgot to remove it. So that's the step that caught me out. Now, we have success, so we're back on track. And so now it's prompting us, well, you've now got something that's worthy of being published as the web service. All right, so at this stage, I think I'm not ready to publish it. We'll see.
Go directly to the end?
Can I go directly to the end?
The arrow going directly to the final bubble
Mm-hmm.
at first and then it aired out. Could you have done? Did you need
I
to?
don't fully understand what you're asking, but I'm happy to take that one offline. All right. Now, what I've just achieved there in that demonstration is preparing. So the scoring experiment was one part, and then you saw I had to sort of manipulate to get the inputs and outputs that I'm after. So the next part will be publishing the web service, which is actually pretty straightforward. So let me just switch back, and now what I can do, because it's highlighted, is publish this experiment as a web service. And it's really as simple and straightforward as that. So as the data professional, I'm now in a position to hand off to a software developer and say, well, now let's integrate this. What's being returned here then is the web service itself in terms of the two methods that it supports. We'll talk about these in just a moment. Request response says that it's going to be synchronous, up, down, sub-second. And the batching says that I've got lots of customers, I want them to be scored, so it's going to be asynchronous, and they'll give me a call back and say, now, in this location you told me is where I've output all of the customers and their scoring. But let's just take a look at the test here. That's a very, very simple test that allows me to come in and say, well, if their 25-year-old is single and is male, and they earn 100 plus, no children, education is bachelor's, occupation is professional, yes, they're a homeowner, commute distance 5 to 10 kilometers. This shouldn't be there. Shouldn't be asking them how much profit they were generated. Unfortunately, it's there. And it's important that they are actually valid values. And here's just a way of just testing and having here in the Azure portal, it will come back with, in just a moment, a predicted value here that says, well, someone like that is going to be classified as very low. Okay, great. According to our data and how we've trained it, that's how it works out. All right, from a managed point of view, now that we have a web service that is deployed, the ops team can come back and be involved here. They can add and manage other endpoints. They can configure endpoint throttling. So this is where it moves from a staging scenario to a production scenario. This is where the pricing starts to increase as well, because what you're really buying here is scalability and the ability to do a lot of predictions within a second. So they can monitor at this point the number of transactions, the compute and storage resources. There's also the potential to publish these web services into the Azure Marketplace and to start earning some money off the predictive models that you've got. So if you've got valuable data and good data science or experimentation skills on top of this, you could publish this as a service that people subscribe to and pay money to use. All right. So demonstration here, very, very straightforward. So managing the web service, I'm really putting the hat on of the Azure Ops team here. So they can manage the web services within a workspace, and they'll find that I've published this predict customer profit class, entering the default endpoint. We have statistics here about usage, right down to the number of predictions within 15-minute intervals. Here under configure is where you can throttle. So currently at 20 calls a second, but there's the potential today for up to 200 calls a second. And with the parallel activity, you're looking at the potential of 4,800 predictions a second is the maximum that's being offered presently. So let me go ahead and save that. And then we move on to the consumption stage. We now have this production web service available on the internet. What that says for the developer then is that you can integrate this into any sort of number of application. I pointed out that there are two particular methods that each web service offers. There is the request response service and the batch execution service. The first is low latency, high scalability. The other is high volume asynchronous scoring of potentially many customers. Now here's the essence of it. From a developer perspective, this service can be called by any programming language from any device, providing you meet these 4 points. That you have internet connectivity, you have the ability to communicate with SSL, you have the OData endpoint address and the API key to authenticate against the service, and the ability to parse JSON responses. So JSON being, and I love this description, it's like fat-free XML. It's text that describes object and state of an object, so it's used commonly in web development. You'll essentially get a single string coming back from the RRS, and it'll say, well, there's an object and the data, and a developer has to make sense of that. And so that's where I'm heading here in the final demonstration. How can I integrate prediction results into an ASP.NET web application? As it so happens, I've already developed the web application. So let me run it for you to show you what this test experience is like. So of course, you would never see in a real e-commerce application that you must enter your profile details. Of course, you're going to use a call to your operational system, look up those details, pass them into the service, get back a value, and then determine the appropriate advertisements that should be displayed for this particular customer. Right, there is no wiring up at this stage. All we have is a series of drop-down lists that do this. How does it work? Well, when you publish the web service, you get some very interesting facts. First of all, there is the API key that you'll protect. This is the authentication to the service. You'll then get documentation for both types of methods. So here with the request response, by clicking on it, full documentation that you can hand off to a skilled software developer. From endpoints to JSON structures, everything is here. Right down the bottom, we even have sample code in C#, Python, and R. So this would be like a great starting point. Let me copy the C# code. I'm going to paste it into a new class of the web application. So figuratively and literally, I will add class to this application. And this will become the prediction service class. How's the resolution for you guys there? All right, so let me know if I need to call something out. Don't need this template. I'm going to paste in pretty much the sample code. All right, now before I go any further, let's understand the goal that's being met here. In the default page, essentially when the submit button is clicked, and a validation is passed, in essence that you've selected something from every drop-down list. What I have here is a class called customer profile. Very, very simple. It's basically a class that just holds a public string value for each of the demographics. So I instantiate this class into the object named profile, and I take all of the values of the drop-down lists and I pass them in. So now I have a single object that represents the customer profile. Down here, ready to do, is I need to retrieve the profit class to determine the appropriate advertising. Assuming that I don't bring back a value of error, I'm going to display that profit class, and then I'm also going to display an image. And let me point this out. It's simplistic, I know, but there are 8 images. 2 genders, 4 profit classes, we have the combination of the 2. So determined by their gender and the profit prediction, will select a particular ad for this demonstration. With that in mind, I need a single method that can be placed in here to retrieve the profit class. Back to the copy and paste with the prediction class here. The comment at the top says that you're going to have to install some other assemblies to support web calls. And that's easily achieved. So let me show you that there are references to assemblies by default in ASP.NET. We have this very convenient way to reach out to the web and bring in a package. So I'll copy this, Tools, NuGet Package Manager. Here in the console, I paste in, and I'm pulling down from the internet a package that consists of 3 assemblies. Notice also here the red squigglies, because it can't resolve these namespaces, but now it can. What it's added is the namespace here for HTTP communication, in addition to Newtonsoft JSON to support JSON functionality. With that in place, I'm going to remove the comments up here. Would it help if I zoom the code up a little? All right. Okay, namespace, well, that's the default. Why don't we go for our test profit class prediction namespace? First thing we see here is a string table. So what the code is doing is ensuring that it can package up a request. So back to the documentation up here. What does a request look like? Well, there is the post request URI, but the headers are here and the request body is here. Essentially, it wants us to pass in, according to these columns, as many customers as we want, comma separated. Because we're only looking up a single customer, we'll just pass in the one customer. So the .NET code reflects that. Here is a class called string table, column names, and as many rows as you want representing values. Let's not remove it. Class program, I think we can come up with a better name. This is Azure Machine Learning. Now, the sample code has been designed for a console application. We don't need this. Remove the main method. And the method here is actually a multi-threaded design. I don't want that as well. So I'm going to replace all of this by saying that I want a public static return a string predict customer profit class. And in order to do this, it's going to need to know details about the customer. So I pass in the object that is of type customer profile. Then it instantiates here an object allowing request response. And within it, it's packaging up the request body. So here in the values, I'm going to start to do this. Profile dot, and turn the insert off. Profile dot age, pass that in. Profile dot marital status. And that's how we're going to pass in all of the values that correspond to the inputs. All right, rather than endure all of that, I am going to pass in a snippet. Okay, but the one thing that I'm going to watch and didn't expect is that profit generated is being passed in here too. So I'm just going to have to pass in a 0. Now that pretty much defines the request body. It is also possible that could be parameters that you pass in. You can parameterize your experiments and pass in values that pass into different properties of other modules. We don't have any today, so that's going to be an empty set. Next thing is, before we can make that request across the internet, is how we're going to authenticate with the service, and this is where our API key gets pasted in. So switching back here, I copy that key. Of course, you would externalize this into an application file or some external resource. You don't want that compiled into the application. Next, the address that it's communicating with. That comes direct from the documentation. And then we get to the point where we're actually going to call the web service. Now, I'm going to remove this documentation because we're not interested in the multi-threading warnings here. And I'm not interested in multi-threading, so if I remove the await keyword and just request the result of the asynchronous operation, I've now got an object that represents the response from the service that had passed into it the score request of columns and values. Providing that we have a success, an HTTP code of 200, it will move forward here. To simplify this logic, I'm just going to return the text error if there is any problem. You could find a better way in your own design. So our focus now is what to do with the response. The response that comes back is called result. I'm going to more accurately call it the JSON string. And that's precisely what I have at the end of that line of code being executed. This is a piece of string that represents the structure of the object and the state of the object. And while you could parse this by hand, this is the technique that most developers would adopt. So switching back to the documentation, we have an example of what the response body will look like. And if you copy that to the clipboard, switch back to Visual Studio and paste it in as JSON, it will construct classes that define that. Edit, paste special, paste JSON as classes, and there are the classes that reflect the response body. I would rather call this RRS, Request Response Service, response body, as a little more descriptive, and I'm going to make these private. I don't want them available to the rest of the application. And then we'll like to format these a little nicer. So essentially they become private classes that represent the response coming back. And now it's reasonably straightforward for me to take that JSON string, first of all, bring into scope that we want the Newtonsoft JSON namespace into scope. On success of a response, we now have a JSON string. So JSON convert. There's a deserialize method that wants to know the type of object. It's my RRS response body, pass in the JSON string. And essentially what I have at the end of that is a variable that allows me simply to come down and say, for my profit plus prediction, under value, under values, because there could be multiple, give me the first row, first column. And we return that because it's a string value. I know that's a little intense, but that's the way it's designed to work. All right, so what I've produced now is an output for my method, a public static method here that will predict customer profit class. I can now switch back to the web application and ask it to go to the Azure Machine Learning class. It will find a static method called predict profit, and then I pass in my profile object. It returns a string, which will now be used to determine the selection of an advertisement. Are there any questions about that? Be aware that you can watch these on Channel 9. So if you need to backtrack and follow this, it should be clear on several viewings, I would guess. Let's put it to the test. So running the web application, unfortunately I get an error. What could this be? So what did I miss? View. Error list, I don't see anything in the error list. This confuses me sometimes. What's the fix for this? Sometimes I do a clean, and I do a rebuild, and I do a rerun. Still doesn't like it. File, exit. It's where I pasted the JSON. Sometimes if I launch Visual Studio, sometimes it works. No. So why? Oh, now it's giving me this. So if I come across here, I didn't rename that. Is that the bug?
Right below you, 2 lines below.
2 lines below, here.
Nope. Right there. That's me and RSS response body.
And that should have been private, so I must have really missed something when I was copying and pasting. Am I on track? Still doesn't like one thing down here. This should be... Rebuild? Happy? Thank you. All right, let's just see if it actually works. So in this scenario, let's imagine a 45-year-old married, we'll go for male, earning highest income, 2 kids at home, graduate degree, management, owns a home, commutes 5 kilometers, submit. holding my breath. It got nothing back. Oh, wow. Okay, anyone notice anything else that I did that I couldn't or shouldn't have done? There was one comment from over there. Okay, I'm not going to pick that up very quickly, but I have up my sleeve a solution. And then I've got this on video. How's this? Providing all going well and that the code worked, we should end up with this type of scenario about here. I'm sure I was very, very close. So passing into the service, it will come back with, for this particular one, high class. Therefore, for a male high class, we're going to use this flashy sports car. All right, and now if we modify this down to someone with a lower education and income, we'll see the prediction comes in not as high, but medium. It's still red, not 4 wheels, but 2. And what if we try this with someone in a lower income bracket? And it's still red and still 2 wheels. And what about someone at the lowest end of the spectrum? So lowest income, single male, young male, partial high school, manual employed, lives close to home but doesn't own it. And I'm guessing this will give us a very low. Do you think it will change with a female? All right, let me wrap up then with a summary. You've seen end-to-end how this is designed to work. I'd like to describe business scenarios and hope to inspire you with these, but before I do, for developers in this room, here is the message. Machine learning is one of the most popular fields today in the discipline of computer science, but it's also one of the most feared by developers, perhaps because the understanding that machine learning is a scientific field requiring deep mathematical expertise. This is true. But what we'd like to bring to your attention is that there's actually 2 disciplines here. There's machine learning and applied machine learning. Developers can apply machine learning by acquiring practical hands-on skills, as I've demonstrated not so successfully in this session. But you don't need to know the mathematical underpinnings of how this will work. So you need the basic skills, working through the flow methodically, designing something that is better than a random guess, and then integrating that into applications. And I believe that this is completely achievable by developers today, whether you're data professionals or whether you are software developers. Imagine what you could use machine learning for then, as I've just demonstrated. Targeted advertising. Churn analysis to detect the customers that are likely to leave from you. You know, it's much more expensive to find a new customer than it is to retain an existing customer. Let's use data mining, and this might explain too why you sometimes get a phone call to say, we'll give you a 5% discount if you renew your phone contract for next year. That's machine learning at work, identifying that you're possibly leaving. Image detection and classification. There is in fact a hands-on lab at this technical event that will walk you through the steps of building up a digital handwritten decoder. Equipment monitoring. There's a lot of money wasted due to unnecessary maintenance, but also due to failures that happen unexpectedly and bring production systems down. Use machine learning and Internet of Things to take in that data and to predict the likelihood of a failure or the need for care and attention with maintenance. Recommendations. Useful recommendations that drive hopefully higher sales and profitability associated with ads targeting. So Amazon do this particularly well. Those that bought this bought that. Forecasting. Spam filtering, anomaly detection, with one variation being fraud detection. So there's a huge potential and business value around taking the data you have today, working through the processes and flows that I've shared with you today, and integrating them in some useful way into a business application. Let's wrap up then with a summary What is Azure Machine Learning? Well, it's a single solution for machine learning. You've seen that the Azure Ops team can provision workspaces. They can then grant privileges for your developers and professionals and data scientists to collaborate together in a web experience to upload data sets, define experiments, create scoring experiments, publish web services. They may consume data from local data you've uploaded, big data with Azure HD Insight, Azure Storage, external web data. At such point in time that you publish a web service, it's off to the software developer to have them to develop against the API service and to do something really interesting. The potential, therefore, is that business users can easily access results from anywhere on any device, providing you've written the application for it. So, welcome to the machine learning of today. With Azure Machine Learning, it's about faster solutions. It's making available to you best-in-class algorithms that Microsoft themselves use in Xbox and in Bing Search. You pay for what you use. So that's the brilliance of the cloud as well. So what you pay for in general terms will be the compute time when you run an experiment or the running of a web service call and the number of predictions. And there are pricing tables around this. You can scale it up as I've demonstrated, so you've got the scale, and of course you'll pay for that. But if you need it, it's just a matter of a slider to bring that up to that 200 value. Quick and easily and extensively use cloud functions and then integrate this into other experiences within your business. In summary, today I hope that you've learned that machine learning is a subfield of computer science and statistics that deals with the construction and study of systems that learn from your data. Key attributes: fully managed, nothing to install, ever. Integrated, using the web browser experience, drag, drop, connect, configure. This makes it really easy, but please do not confuse this with machine learning being easy. It makes it easier for you to experiment. Best-in-class algorithms, bring your own R or Python in as well. And as I've demonstrated today, you may deploy within minutes and operationalize your predictive modeling. Key point for this session is that machine learning is now approachable to you as professionals and in particular as developers. I wrap up with a variety of resources. Certainly the documentation is quite complete. So it's well worth reading through the documentation and the samples. The FAQ is a great place to go and see answers to commonly asked questions. And the pricing, and I'd like to point this out, is that there is a free tier that requires not even an Azure subscription or a credit card. So not only can you work with it today on your flight home using the in-flight internet, you don't even need to pay for it. How good is that? In addition, there's the gallery. Go ahead and learn from others that have contributed their experiments, and that might be your learning path to becoming a master in this area. Revolution Analytics, Microsoft made this acquisition back in January, so you no doubt are hearing some announcements at the event this week. But there's promise here, and we're already seeing that SQL Server will be embedding R and predictive analytic capabilities in its next release. So stay tuned for more on that. Lastly, there is this one publication. I've had a read of it. I think it's very good entry level. It has chapters dedicated to particular scenarios, whether it's churn analysis or monitoring of equipment. And so it's a nice, easy first journey into Azure Machine Learning written by these three professionals. Now, if you don't trust anything that I've said here today, I will include the link to Paul the Octopus, and you may research him and his predictive capabilities, although I will share with you he passed away in some recent times. All right, on that note, I'd like to wrap up by stressing the importance of feedback. Could you please take the opportunity to feedback what your experience here was? If it was great, we'd love to hear why. If it wasn't meeting expectations, we'd also like to hear why. Beyond that, I will thank you for your time, attendance, and your interest in this topic, and I wish you all the best in your machine learning adventures. Thank you.